If we're given a tabular function, we're going to create a new row to represent a horizontal shift. So step 1, we want to identify the input row or column. Number 2, we're going to determine the magnitude of the shift. And number 3, we're going to add the shift to the value in each input cell. So for example 4, we're shifting a tabular function horizontally. A function f of x is given in table 4. We want to create a table for the function g of x, which is equal to f of x minus 3. So here are our inputs, 2, 4, 6, and 8. And our outputs are 1, 3, 7, and 11. So again, let's take a look at this. So this means that if I take a look at the input, which is x minus 3, and set that equal to 0 and solve for x, we would get plus 3. So what that means is we're going to be adding 3 to each input. So the formula g of x, which is equal to f of x minus 3, tells us that the input values of g are the same as the output values of f when the input value is 3 less than the original value. So for example, we know that f of 2 is equal to 1. To get the same output from the function g, we will need an input value that is 3 larger. So we input a value that is 3 larger for g of x because the function takes 3 away before evaluating the function. So if we take 2 and then we add 3, then we get an input of 5. So that g of 5, now we're going to plug it in. We get f of 5 minus 3, which gives us f of 2. And we know that by looking at f of 2, the output gives us 1. Likewise, we take the input of 4 and then we add 3 to it. And therefore we get g of 7. So we plug in 7 in for x. 7 minus 3 gives us 4. So f of 4, according to this tabular function, gives us an output of 3. Next, if we take 6 and then we add 3, that's going to give us 9. So g of 9, we plug it in for x, so f of 9 minus 3 gives us f of 6. And the output of f of 6 is 7, so now we have the output of 7. And then 8, for the input of 8, we're going to add 3, so we get g of 11, which is equal to f of 11 minus 3, which gives us f of 8, and therefore we get 11 as the output. So when we continue with all the values to create table 5, we know that we now have these new inputs, which are adding 3 to get 5, 7, 9, and 11. When we subtract 3 to that, we got 2, 4, 6, and 8. So therefore, the outputs are going to remain the same for f of x and g of x. So the result is that the function g of x has been shifted to the right by 3. Notice that the output values for g of x remain the same as the output values for f of x. But the corresponding input values x have shifted to the right by 3 units. Specifically, 2 shifted to 5, 4 shifted to 7, 6 shifted to 9, and 8 shifted to 11. So let's take a look at this. So here are our original ordered pairs. So our original ordered pair was 2, 1. And then we had 4, and then 3. And then we had 6, and then 7. And then we had 8, and then 11. Now, to get these new ordered pairs, okay, this is what we've done. Since it was a horizontal shift, what we've done is we've taken 8, added 3 to it, and the output stayed the same. We took 6, added 3 to it, and the output stayed the same. We took 4 and added 3 to it, and the output stayed the same. And then we took, again, the input, added 3 to it, and the output stayed the same. So then our new ordered pair end up being the following. We got 11, 11. We got 9 and then 7. We got 7 and then 3, and then 5 and then 3. Because again, what we were dealing with was the horizontal shift. So we changed the x values by adding 3 to each input.